Hey everyone, welcome back to my channel. Today let's solve the problem subsets. We're given an integer array nums. All we need to do is to return every single possible subset that we could create from the original input. And we don't want to include any duplicate subsets. So what is a subset? Well, let's say we have 1, 2, 3 as input. One subset, of course, will be 1 by itself, right? And 2 by itself. And we could do 1, 2 together. But now, what happens if we do like 2, 1 together? Does it count as a different subset or the same as the 1, 2? Well, they're the exact same one, right? Because we don't care about the order in the subset. It's not a permutation, it's a subset. We do not want to include any duplicates, and this counts as a duplicate, so we're not gonna include it. And 3 is another subset. 1, 3, 2, 3, 1, 2, 3. The original input is technically also a subset of the input. And we don't want to forget the empty subset because no matter what input we're given, an empty subset is always the subset of the input. If we want to create all the subsets for the given input, we need to make a choice for every single element in the input. Say for this one, we have two choices. One is to include this one in the subset. Another one is not to include the one, and we will have the empty subset. So for every element in the input, we will have two choices here, two choices here, and two choices here. So we will have 8 choices. Or another way, 2 power n. The n is the number of the elements in the input. So we will have, different size of subsets. We'll have a long one with like 1, 2, 3, and like just 1, 2, or just a single element. So in this way, the time complexity will be 2 to the power n. The n will be the number of elements in the input. Now we can draw a decision tree. So first we can decide whether to add the 1 or not add the 1. If we add the 1, we will have the 1 in the subset, and if not, we will have just an empty subset. So along the left-hand path, we will decide to add or not add 2 into the subset. If we choose to add 2, we will have 1, 2 in one subset. And for the empty one, we will have just empty subset. And for the right-hand side, we will have a single 2 or an empty subset. So the same one, we will have 1, 2, 3 together. And 1, 2. And single 3. And then empty. And 2, 3. Single 2. And empty. And for the last branch, we'll have 3 and empty. So we will have 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3, and empty. 8 subsets in total. So let's do this with backtracking. So we're going to have a result list to add the subsets we're going to have. I'm going to do this with backtracking depth first search. So I'm going to write this function inside. So we don't need to like pass in this variable and this variable in it. We will just have access by default. But I'm going to pass in the I, which is the index of the value that we're making decisions on. So I will tell us which element we're currently visiting. We know the basic case for this will be if I happens to out of bound, like equal to the length of nums, we will know that it's out of bound. In that case, we can just return. So what data structure I'm gonna to use is a list to build each subset. I'm gonna allocate this variable outside of the function because we will have the global access. So for the leaf case, we will just add the subset into the result list. So to notice that we not just append the subset, we append the copy of the subset. Because in some languages, we don't want this variable to be modified in other places. We use copy to make sure we have the exact correct value that we want. And we know that we have two decisions to make. So the first decision is to include the current number into the subset, and the second decision is not include this number. So for decision 1, if we include the current number, we will just append the current number into the subset and call the depth first search with the index +1 to search the next value. And for decision 2, we will not include the current number. So basically, we are skipping numbers by. How am I going to do that? I'm going to take the subset and pop the element we just add into the list. Then I'm going to recursively run the DFS, depth first search. So these two functions calls are in the same way, but slightly different, because one is to include the current number and one is not. And the last thing we need to do, don't forget to call the DFS out of the function with the argument of 0 to pass in, and then return the result list.